Welcome to another video on the xsTECH router. Recently, several people have been asking us, so just how easy is this machine to set up and use? And I'm excited to say it's one of the easiest and most intuitive machines that I've ever had the chance to use. And I've had the pleasure of using several machines to teach CNC to my students like Haas and IMCO and IntelliTech, and the machine itself is very similar in setup and operation, but it truly is the software that makes this machine fun and easy to work with. And the software for this machine is the same for all of their machines, so any skills and knowledge that we learn can easily be transferred from the xsTECH router all the way up to their 1100. Just a quick disclaimer, this video is only designed to show you how fast and easy you can get your machine out of the box and up and making chips. There are a ton of other ways to set up the software and use it, as well as setting up your parts, but we'll get to those in later videos. So without further delay, let's get started. In order to get any CNC machine up and throwing chips, we think that there are 5 essentials that you must know about any machine. Number 1, how to get the machine safely powered up and running, and also how to power it down safely. 2, how to install and change tools. 3, how to teach your machine where your part is located on the bed in the X and Y. 4, how to teach your machine where the end or bottom of your tool is on the Z in reference to your material. And finally, number 5, once you have some kind of NC code, how do you load it and run it? Alright, so let's start with number 1. How do we start up and shut down your machine? Once you have everything plugged in, make sure the e-stop button is pressed and turn on the main power. The switch is located on the back bottom left of the machine, and we'll wait for the main screen to appear. Note, if this is your first time turning on the machine, it may ask you to set up a wireless network, which can be skipped and ran again later. I think it also asked me to pick the machine I was using. Remember, this software is the same for all the machines on that list. Alright, once the controller is completely powered up and we're sitting at the home screen, we can go ahead and release the e-stop button by twisting it clockwise. You should feel the button kind of pop up, and really that's it for the power up. We now need to open communication between the controller and the machine, and we'll do this by clicking the reset button inside PathPilot. Alright, we now need to reference or home the machine in all 3 axes. But note, I always reference the Z-axis first before the X and Y. This really is just to ensure that the spindle is sitting at its highest point to avoid hitting or catching on anything that it may run into as it sets the X and Y. So select reference Z and wait for it to stop before referencing the rest. Okay, now we can go ahead and reference the X and the Y. Alright, our machine is ready to go. We're going to repeat that same process every time the controller is powered up. And the last piece of this essential is how to safely power down the machine. Go all the way down to the bottom right corner of PathPilot and select Exit. A notification box may pop up if you've not already put the machine in e-stop mode. If it does, press the e-stop button and then select OK. PathPilot will let you know on the screen when it's safe to turn off the machine, and since the controller is plugged into the machine, when you turn off the machine, it will also turn off the controller. Well, that's it. We need to know how to load and unload tools. For this machine, we're going to need 3 things: the collet nut, the tool I want to install, and the collet that matches the shank size for that tool. The tool I'm going to load first is the taper-ended ball mill, and if you look at the tool's container, you'll notice that there's a set of numbers. The first number is the tool's shank size. The second is the cutting diameter, the third, the length or depth of cut, and the last one's the tool's overall length. So this tool will need a 4mm diameter collet. The number just happens to be noted on the face of the collets. You have a 6.5, a 4, and a 3.5. So the middle size is the one that I need. Okay, now let's test the collet that we chose. The shank should smoothly fit down inside the collet. I'm happy with that. Now that we've chosen the tool and the matching collet, we need to install the collet into the collet nut. The collet doesn't just drop down into the collet. It has to be, well, kind of rolled or snapped into place. This is what helps pull the collet down and out of the spindle when you're removing the tools. It's really hard to see here, but if you look down inside the collet, you can see that one side has a small lip that the collet lip has to roll underneath. It should catch on this little lip of the collet, and you can kind of feel it snap into place. When the collet's in correctly, it should almost be flush with the top of the face. And if you shake it, the collet itself shouldn't fall out. Taking it out is really the same process. The collet can't be just pulled straight out. It has to be, well, rolled back out. You may need to also press it a little bit from the other side to get it to completely release. So let's snap it back into place and go reinstall it into the machine spindle. Okay, back at the machine, we can now screw the collet nut and the collet back onto the end of the spindle. And we can slide the tool up into the collet. And I like to take a shop rag or a soft cloth and press up on the bottom of the tool so that I can push it up into the spindle as far as it'll go. We'll slide the small wrench onto the spindle and hold the collet nut with my fingers and just lightly turn the nut until it's finger tight. This should be enough to hold the tool in place while we finish snugging it up the other wrench. To tighten the collet nut in place, turn the wrenches into each other. And it's the same process to remove the tool. We'll again use both wrenches just to break the collet nut loose. Turn the tools away from each other. And I'll grab onto the tool to keep it from dropping out and use my fingers to loosen the nut enough to go ahead and pull the tool out. And that's it for installing and changing tools. Now that we can power up the machine and load a tool, we now need to teach the machine where your part is located within the machine's environment. For this step, we're only going to focus on the X and Y of your part. The machine needs to learn where your part is sitting in reference to its own home position, or what's known as the machine's home or machine zero. This distance is referred to as the work offset. For some machines, this can really be a pain, or at least several steps in and out of different screens. PathPilot makes finding and saving this location extremely quick and easy. So we need to teach the machine how to shift its own zero over to our part zero. And then we need to store this somewhere. We're going to store this location what's known as the G54. The G54 is the machine's primary work offset. There are several methods for finding a work offset, and they all deal with things like accuracy and precision, how easy and quick it is to even do, and if the position is reusable or refindable for times when we need to repeat a process over and over, or even if we need to take the part out and put it back in to run another operation on something like a different face. For now, I'm going to show you the quickest and easiest, but really the least accurate. But this method is going to be more than good enough for now, and good enough for the way that I've designed in my one-sided part. This is known as the eyeball method, or as we referred to it as the ILAR method. That stands for it looks about right. For the eyeball method, I love to use an engraver or a tapered end mill. Since it comes to a point, it's much easier to find and locate over the corner of our part with the tool's tip. We're going to use the jog pendant or shuttle control to manually drive the end of the tool over and down to the corner of our part. Every time a part is designed, it's designed with a known location on that part that can easily be referenced or located within the machine. And a good majority of the time, the top front edge is my X-axis, the left is my Y, and well, the top is my Z, but we'll get to that part later. I'm going to manually drive the tool over and down to the front corner and store this location as the X and Y for my G54 offset. To do that, let's first take a look at the jog pendant itself. You can see that it's broken up here into its X, Y, and Z. The rest we'll get to. There's also a small dial in the middle that we'll get to later, but it's the outside rubber ring that we want to use for this process. Hopefully you can already see that it's labeled as a positive and negative direction as well. Negative goes counterclockwise and positive goes clockwise. But before we can do that, there's some things you need to understand about the machine. You really want to only think about the end of tool of the part that's moving and not the rest of the machine. If the tool moves to the left, that's the negative X direction, and if it moves to the right, that's the positive X direction. But those are the easy ones. If the tool is coming forward, that's the negative y, and if it's going backwards, that's the positive y. It's backwards if you're thinking in reference of how the table's moving. So play around with driving the machine a little bit until you get the hang of it. Alright, I'm going to start off with the x-axis, so I'll press the x button. And I know I want the tool to move over to my part, so I'm going to turn the outer ring clockwise to move the x-axis in the positive direction. And you'll notice the more you turn the dial, the faster it'll travel. Alright, I'll now choose the y-axis, and I know I want the tool to come forward. The table's going to go backwards, so that'll be in the negative direction, so counterclockwise on the dial. Alright, even though I'm not going to be recording anything with the Z at this time, it'll be a lot easier to tell when I'm over the corner if I bring the tool down close to the material. So I'm going to go ahead and select the Z, and I'm going to move the tool down, which is in the negative direction. Alright, I'm going to continue playing with the X, Y, and Z until I'm right over the corner of my part. Alright, I'm really happy with that location. If you get down eye level with the top of the part, you can really see how close you are to the corner, and I think typically we can see an accuracy of about 10,000ths of an inch or so just by eyeballing it, and I know it'll at least work for how I've designed my part, which I'll show in another video if you want. Alright, and the last step is to record these values as the work shift numbers for our G54, and by default the software is already set up to store them in the G54. There's nothing to do. All I have to do is come here to the X0 and Y0 buttons, and PathPilot will truly take care of the rest. So I'll press the X0 and the Y0. There we go. If you're wondering where the numbers came from that were already in the boxes, those were the work shift numbers from the last time I set up a part. And that's it. Yep, that's really it. The machine can now locate the X and Y of your part. Okay, we can now start up and shut down the machine. We can load a tool. We've located both the X and Y of our part in the machine's work envelope. We now need to teach the machine where the end or bottom of our tool is located. And you may be wondering, why didn't we do that in the last step while we were there? And well, because that's not the tool I'm going to use to create my part. I only had the taper mill installed so I could find the corner. So I've now loaded the tool that I want to use, and I'm going to bring it down to the top surface of my part. Okay, I'm going to go ahead and select the Z-axis and start bringing the tool down to the top surface of my part. But there's a little bit of a problem. When we were locating the X and Y earlier, if we went too far, one way or the other, it really didn't matter. We could just go forwards and backwards. If I go too far down in the Z, I'll run into the top of the part. So we're going to switch to a different method. We're going to use a scrap piece of paper to tell when we're right above the stock. I know this piece of paper is about 0.004 of an inch thick, and I'm going to shift the little piece of paper back and forth while I'm going down until I can't move the paper anymore, or just until I feel a slight drag on the piece of paper. The only thing I'm really going to change is the way I'm going to move on the Z-axis. I'm no longer going to be using the outer ring of the jog pendant. I'd like to have more control. I'm going to use the step function of the pendant. The step motion is controlled by the little inner dial. The problem is, you really don't know how much step increment you're moving when you rotate the dial. But if we look at the screen, you can see we're currently on the default step of 0.00025. What is that? 2500,000ths of an inch? Using this method, I really don't need to be that accurate. So I'm going to hit the little step button, and I'm going to shift over to the 0.001, or 1,000ths of a step increment. That's the quarter of the thickness of a piece of paper, which is more than accurate for the way I'm doing this. I do want to make sure that I'm traveling in the negative direction, down, counterclockwise, and I want to make sure that I'm using the inside of the dial, and every time you feel a click, you've traveled 1,000ths of an inch. So I'm going to keep shifting the little piece of paper back and forth until I feel drag. And there, I have just a slight amount of drag on the paper. Not enough to bite into the paper, just enough to tell me when I'm up against the paper. So I'm about 4 thousandths up in the air away from the material. I can now go into PathPilot and just click the 0Z button, or I can go ahead and zero out the axis, and then I can actually click in the box and type 0.004, about the thickness of a piece of paper, and hit enter. I've now taught the machine that the tool is currently sitting 4 thousandths of an inch above the top of the material. That's so cool. And the final skill that we need to get any machine up and running is probably the easiest, well, at least for this machine. We need to load an NC file onto the machine. How you get or create the file is going to be different for everybody, but for a quick example, I'm an Autodesk inventor, and I'm going to go up to my Post Processor option. I'm going to make sure that I'm using the Tormach PathPilot Post Processor configuration, and I'm going to post the file and save it to my USB drive. I can now move the file over to PathPilot. Loading a file in PathPilot is really easy. I'm going to go over here to my File tab. I'm going to go ahead and plug in my USB drive. I'm going to wait a couple of seconds. And voila! The USB folder management should pop up. Highlight the file that you want to use and select Copy from USB. Once it's copied over, if you highlight it, you'll even be able to see a preview of the G-code over on the right-hand side. If you just so happen to need to edit the G-code, you can even do that right in PathPilot. It's a full editor that will allow you to search the code for things like tool changes or replace speed rates and feed rates with different values. This part is really cool. But for right now, all we need to do is either double-click it or select Load G-code. The software then jumps back to the main screen and will load the code up for us. And just a few quick tips about the display window while we're here anyway. If you right-click on the display window, you can change how the part is represented. I love the isometric or ISO view. That puts your part, well, at least the tool paths of your part, into 3D. It even shows where the origin of your part is and where the part is in relationship to the machine's work envelope. If you click on the bottom of what's usually your web wheel, you can then zoom in on the part. If you click and hold the top of the web wheel, you can even pan around on the part. Those are just a couple of quick things that I've found and love. I'm still finding so many cool things about this software. So I guess the last thing would be to run the program. We can do that by selecting Cycle Start. So, for those of you that made it this far into the video, we really hope you learned something new, and we hope that this video helps you get your machine up and running. We'd love to see what you're doing with your machine. I'll be posting a video that quickly runs through all of these steps for an actual part, and I'll share the part file with anybody that wants to try it themselves. Thanks so much for watching.